All right, so we've talked about what erosion is, and we've also looked at why erosion can be bad and the problems that it can cause for us. So the logical next step in this process is, well, what can we do to control erosion so that we don't have those problems that we don't want? We don't want to lose the land underneath our house. We don't want our roads to be washed out. We don't want to have a landslide or mudslide take out a whole neighborhood. We don't even want small erosion like creep to kind of make my hills and my fences and my houses slowly move downhill. All that stuff is bad. So these next 2 days are going to be looking at what can we do to control erosion. And there's basically one of two things that you can do to approach this. The first is working with water, and that's what we're going to look at today. All right, now remember what determines the amount of erosion. If we're talking about water, there's two things that make erosion more or less. If we have more water, there's going to be more stuff moved, more erosion. Or if the water is moving faster, you know it's going to move more stuff, cause more erosion. So basically, controlling erosion by water means you either have to address one of those two issues or both. You either have to make water slow down or you have to make it where there is actually less water. So how can we make water slow down? We'll address that first. This is the one that's a lot more typically done, and it's kind of new for us here in this presentation. First of all, consider this situation here. Over here, we've got a road, and we know a road is an impervious surface. It is going to cause a lot of runoff. Now, on a road, we actually want water to get off of our roads very quickly. Because when we're driving our cars, we don't want to drive our cars in a lot of excess water on the road. So roads are designed so that they slope in such a way that the water will slide off the roads very easily and very quickly. But that means when the water comes off the road, there's a lot of it and it's moving pretty fast. Now, we're going to move that water to a storm drain. But as it's moving towards the storm drain, if it moves across the bare ground, it's going to pick up some of this dirt in here and try to move it. And if too much of that dirt gets moved, eventually all of this dirt could get moved and my road could collapse. So we need to do something to keep all of that sediment, all that dirt from getting moved. Well, the first thing we can do is make the water slow down. And what we can do here is as the water gets into this drainage ditch and it's trying to come down here, downhill to a storm drain, we can put something in the way, like these piles of rocks, and the water kind of has to stop for a second. It kind of comes downhill and that kind of stops, and it kind of either has to go around or it'll go through because it's not a solid barrier, or it'll go over the top. Well, then it goes a little bit further, has to do the same thing again. Goes a little bit further, has to do the same thing again. These piles of rocks that you see strategically placed in the path of water help to make water slow down. They're like speed bumps for water. And the whole purpose of these is to make water slow down because slow water doesn't move as much stuff as fast water. Think of this situation here. It's going to rain. This is here in Georgia. Get a lot of water on our parking lot, and I want to get that water off my parking lot as fast as possible. So I let it drain over here. Try to get to the drainage ditch and the storm drain. The problem is all of this dirt, once again, is soft, and the water, if it comes off the parking lot too fast, will move the dirt on my parking lot. I can't have that. So what we do is we put these rocks in the way, and when the water is coming off the parking lot, it kind of has to take its time to kind of filter through the rocks. Or even if it goes over the top of the rocks, it has to slow down a little bit. So these piles of rocks are put in the place of water to act to make water slow down. Now they have a name. These are called riprap. Riprap are piles of rocks that are put in the path of water to make water slow down. They're like speed bumps for water because we know that if water goes slower, it won't cause as much erosion. You'll see these round drains all over the place. If you notice this area right here, you can see where there's been a fair amount of stuff that was moved because the water was coming off of this drain here. And it looks like they came back in and they added some rocks. They said, you know what? Looks like we're having too much erosion here. Let's put something here that's going to make the water slow down. That's the riprap. That's the rocks. This is right around the corner from us here at Centennial, right over on Eves Road where the new neighborhood is. Got some houses up here, and houses are impervious surfaces, and when the water runs off the house, it runs into a drain, and it actually spits out here. Well, it's coming off the top of the house. It's going to be falling pretty quickly. So we put rocks in its way to make the water slow down so that it doesn't erode the land underneath my sidewalk or my street. It doesn't have to be just a straight pile of rocks either. You can use anything in the place of water that's going to make water slow down. In both these cases, water's coming off this parking lot and it's going into the drainage ditch again. Well, we want to make it go slower. So when it hits this little pile of concrete, it has to stop and go around first. That makes it go slower, less erosion. Over here, this is a practice field at Laster High School made of turf. And when it rains, you want the water to get off the turf as fast as possible. So athletic fields are built to make the water move fast off of the playing surface. Well, here's the drain where it comes out. Well, as it's going to the storm drain, or the drainage ditch actually, we don't want it to go that fast. So we put it over here where it has to kind of like hit and weave its way through those rocks that were set in the drain path, so that makes the water go slow down. We looked at this guy before. Here's a dude that was having a problem with his patio, and his deck looks like it was getting ready to fall off his house because he was having water moving down this hill pretty quick. You can see it's pretty steep, and you can see the erosion happening. He doesn't want to have his hill that his house is on move. So look what he did. He came back and he put some big rocks right in the path of where the water has been moving. That's going to make the water slow down, and that's going to lessen the amount of erosion. Now, a Gabbion. A Gabbion's a little bit fancier. A Gabbion's not just a pile of rocks. A Gabbion is a wire-filled cage of rocks. Sorry, it's a rock-filled wire cage. I said that backwards, but you get the idea by looking at it. It is a rock-filled wire cage that makes water slow down so we have less erosion. And it's the same concept. Water's coming down this hill right here, and it's trying to get to a slow point. Water coming down the hill, it can get through these rocks, but it takes a moment. It has to kind of weave its way in between the rocks, and therefore the hillside doesn't get moved. Now, Gabions are built places where the erosion is going to be a little bit more severe. They have the wire cage around them because you can build it up higher, make it a little bit sturdier, as opposed to just kind of like a random pile of rocks. So you use Gabions places where you know the erosion is going to be a lot bigger deal. Now, curved drainage. This is a simple concept. It's not really a vocabulary term, even though I put it on the vocabulary list. A curved drainage, you'll see this because drainage channels aren't made to be straight generally, because if they're straight, the water can get going really fast. A curved drainage, as water comes down through the drain, it kind of hits this side, bounces to that side. It kind of keeps having to bounce back and forth as the channel curves. Well, that makes water slow down, and slower water will cause less erosion than faster water. So a lot of drain channels are made to be curved in order to make water slow down. You can see it here. This was brand spanking new, and you could see from here to here, it seemed like it would have been a lot easier to make a nice straight channel, but they didn't. They made this curve so that the water kind of has to snake its way through there, which means it has to go slower. It's going to cause less erosion. You can see it here too. This is a house in my neighborhood. The guy made his drain from his house curved because he didn't want the water coming off the house going so fast, because he didn't want to lose his yard when the water was leaving the house. Same concept here. It goes this way, kind of curves before going that direction. So anytime you have drainage, you attempt to make it a curvy shape because that makes water slow down. Here's an example where they had curved drainage and they had some riprap. So water coming off the hill up here, and you can see it curves around, and they've got big rocks in the way of the water. So we've got a combination of things. We've got the drainage being curved, and we've got that riprap to make water slow down and lessen erosion. So what if the water's going downhill? We know that if you have a steep hill, the water's going to go faster, and you're going to have greater erosion. So if we can change the hill and make water go slower, well, then we would have less erosion on our hills.
Okay, so here we are in Panama, and we're in a place where it rains a lot. And they cut through the land to make the Panama Canal. And they had to make the land extra steep when they cut into it. And because it rains so much here, they have to worry about extra sediment coming down the hill and into the canal, which you don't want, because then it fills up the canal with dirt and your ships can't get through. So what they did here was they cut those little flat steps into the side of the hill. And what happens when it rains up top and the water starts to come down the hill, every time it hits one of those little flat parts, it has to slow down a little bit. And slower water doesn't cause as much erosion as faster water. So by cutting those little flat steps, you don't wind up with as much runoff. You don't wind up with as much sediment down here where you don't want it. This process of cutting little flat steps into the side of a hill to help reduce erosion is called terracing. Once again, terracing is cutting little flat steps into the side of the hill, which makes water slow down so it doesn't carry as much sediment or cause as much erosion.
Here you can see it in North Georgia. They made this new highway. They made it wider, and they had to cut the hill steeper. Well, water is going to come down the hill this way, and we don't want extra sediments to wind up down here. So we want to make the water slow down some. Well, water comes down here, and it gets to this little flat part, and it has to slow down before it slides the rest of the way down the hill. This is called terracing. All it is making flat sections into your hills, so the water has to slow down. It can't get going so fast. Here you can see lots of examples of these around the South, especially because it rains a lot and we have a lot of hills. So we have a lot of erosion problems, especially beside highways where we cut into the hills. And you can see each one of these hills has a little stair step on it. This one's got 2 or 3. This one has multiple stair steps. And every one of those little steps makes water slow down, so you'll have less erosion. Here's another really extreme occasion. This actually looks like a set of steps, and it's paved in concrete. And every time the water goes down one of those steps and hits the next flat area, it can't get going very fast. It has to kind of stop for a second before it goes to the next step. Slower water, less erosion. Now, we do this a lot in our area. You see this in yards, especially places where people have very steep yards. And you've probably never thought about this before, but now you know. People didn't build these yards to be like this just because they wanted little stair steps or little terraces in their backyard. They did it to help control erosion. It rains a lot in our area. We get a lot of runoff. But you don't want to lose your yard. You don't want your water running away from your house to take your yard away. So a lot of our yards and our neighborhoods in this area have these little terraces so that when water tries to run downhill, it has to go slow here, here, and here, every place where it's flat. If the water slows down, it's going to cause less erosion. So this is kind of a little visual summary. You can kind of stop, take stock of this, sketch this diagram in your notes, because I will ask you on the assessment, okay, here's this diagram. Kind of explain to me what's going on with why do we make hills this shape, especially in our area. You'll see this with walkways. Here's a walkway in a park, and the hill isn't very steep. You could walk down this hill pretty easily, but you'll notice what they did was they made these flat little steps so that when water goes down, every time it goes down a step, it has to slow down a little bit. If they didn't have those little steps, those little terraces, the water would go down really fast and it would continue to erode my path. I'd wind up with a big, huge cut in the land there. Now, with farmland, farmland's a very special case where farmers have to fight erosion because they want to keep their soil because that's what their plants grow in. That's their livelihood. So the question becomes, how can a farmer make water slow down and not cause as much erosion? Well, it used to be in the old days, farmers used to plow straight up and down hills. That was the easiest way to go. You walk straight up the hill and straight down the hill as opposed to going sideways. The problem is when it rains, the water gets sliding downhill in those little channels with nothing in its way, and it's going to carry away a lot of your soil. Well, farmers want to keep their soil in place because that's what their plants grow in. So here's what farmers started to do. Instead of plowing up and down the hills, they plow across the hills. And now when water comes down the hill and it has to go between each little rut or each little furrow of plants, it has to stop and get over the little hump where the plants are. It's like a little mini speed bumps again, makes water slow down, which means it doesn't pick up as much as of the soil and carry it away. And that's a good thing, a very important thing for farmers because they need that soil to grow their crops. This process is called contour farming. This is where we plow the land across the grade or across the hills instead of up and down. And it makes water slow down and cause less erosion. You can see it from the air a lot of places. You'll see these kind of weird, kind of funky shapes in farmers' fields, and that's because they are following the shape of the hill and not going in a straight line, which would maybe cause more erosion. Now, an extreme case of that would be what we call a terraced field. Here's in Southeast Asia where it rains a lot and they got really, really steep soil, steep land. So every time the water goes down, it has to slow down. And that keeps the soil in place. It also helps to allow water to infiltrate the ground. Remember, because if water's going slowly, it's a lot more likely to infiltrate, which is what you need because your plants on that soil need the water. If it was just a straight hill, the water might run off too quickly and the plants wouldn't get enough of the water. Now, there's other ways to make water slow down. We see this a lot in our area here. We see a lot of use of pine straw or these pine bark nuggets or mulch. We see this in any new construction site. We get hay that is placed out, and all of that is actually used to make water slow down. Well, this is how it works. Basically, when it rains and the water falls onto the hay or the pine straw or the mulch or whatever, it doesn't hit the ground immediately. It kind of has to snake its way in between all the pine needles. Now, it can get through, but it slows down a little bit. And anything that causes the water to slow down is going to cause less erosion. It also is going to allow more water to infiltrate. Remember, if the water kind of stops for a second, it's a lot more likely to go into the ground than become runoff. Once again, it's going to make less erosion. So in our area, you're going to see this a lot. We have steep land. Nobody's going to plant grass up here. It's just too steep. But they can't leave the ground bare either because every time it would rain, and it rains a lot here, all of my sediments would come down here. So they cover the ground with pine straw. And now when it rains, the water has to kind of like sneak its way in between all the pine straw, and therefore it moves slowly and it doesn't erode my backyard. Now, when you have new construction, you're going to see this spread out in the ground. You're going to see hay, especially while construction is going on. Because look, this is all red clay. We know clay is going to move very easily. And while it's just bare clay, it's going to rain before they finish construction. Well, you got to hold the sediments in place because we don't want this clay to get down here, get in my storm drain and clog it. So one of the things you can do temporarily is you put hay on the ground, and that makes water slow down. Most cases, especially in our area, this is actually required by the government. If you want to build a new house, you want to build a new neighborhood, any new construction, They're going to make you put hay in the ground to help lessen the amount of clay that gets picked up by water and moved into the storm drains. Now, I showed you this before. Here's Alpharetta High School. This is years and years ago, not too long after Alpharetta was built. And you get the idea here. Water was coming off their parking lot, and it's coming down here. Down here, you can actually see the water, a little bioswale down there. And the water wants to come off the parking lot and get to the bioswale, which is okay. That's where we want it. But you can see it's moving a lot of the sediments. Well, if too many sediments get moved, it's going to move the ground under the parking lot. So I came back a couple of years later and I said, well, let's see what they've done. Now look what you see in the same picture. The cut in the ground is now a lot bigger. And look what they did, at least temporarily. They've kind of stuffed that area with pine straw so that now when water comes off the parking lot, it kind of has to snake its way through the pine straw, and therefore it goes slower and is going to cause less erosion. Now, a straw wattle. A straw wattle is another temporary thing, typically used during construction. And you can see what this is. This is just a roll of hay that is used to make water slow down. That's what a straw wattle is. You can see, this is a close-up of it. It's just a little net, and as water is going to move downhill, it can go through the wattle, because you see it's not a solid material, but it takes a little time for the water to weave its way through there, which means it then has to go slower. Slower water means less erosion. A straw wattle, just a roll of hay that makes water slow down, therefore lessens erosion. So one of the big ways to control erosion, lessen erosion, is make water slow down. But remember that erosion is also dependent upon the amount of water. So if there were somehow a way to make less water, there's going to be less stuff moved or less erosion. So how can we make less water? Now, we can't change the amount of rainfall. The rain is going to fall, but we can control how much water goes where. Going back to bioswales and retention ponds, things that we studied last unit, all of those things help to reduce the amount of runoff. Well, if you have less runoff, that means you're going to have less water moving across the ground and picking up stuff and causing erosion. So all of those things that lessen runoff also help to control erosion. But we're still going to have runoff. I mean, we just can't make zero runoff. It's going to rain, and water is going to hit even natural surfaces and become runoff. So how can we make natural runoff where it doesn't cause as much erosion? First and foremost, let's not let the water go across the bare ground. Let's not let water pick up sediments and cause erosion. So let's get that water to storm drains and retention ponds before it is able to pick up sediment. So make less water going across bare ground. Get the water to the storm drains as soon as possible, because it can't pick up and move the concrete, but it can pick up and move the dirt. Both these cases here, we got two houses and they've got these drains right here. These drains are connected to the downspouts from the house. So when it rains, water comes off the roof of the house and goes down this pipe and then comes out here. I want less water near my house, because remember, the more water I have in the ground near my house, the more likely I can have erosion, even like that creep erosion where it happens really, really slow. So this is a way where we can make less water someplace, and less water in a location means you're going to have less erosion. Now, look at this guy. He's got the same problem. He's got a house and the water slides down the house and it's going to come into the ground. But instead, he ran this drain pipe way over here away from his house because he wants less water in the ground next to his house, because he doesn't want the ground next to his house to move. So less water in one spot means you're going to have less erosion. Now, this is that Pacific Coast Highway that I showed you in California where erosion is really, really bad. The road is always closed and they're always constantly fighting erosion. Here they're going to use drains and pipes to keep water away from the road. We don't want any water in this ground right here, because if that ground gets wet, it's likely to move. So all up and down this highway, they have lots of drains, and then they have lots of pipes to keep water away from the road. They make less water on the road or in the area of the road. Well, if you have less water, you're likely to have less erosion.
So here we can see a really steep slope where stuff is going to want to move very easily. And we don't want stuff moving down this hill and winding up out here on our road. If you look over here, you can see what this hill is made out of. It's pretty soft, loose material that would get moved very easily. And of course, this hill is really, really steep, so gravity's going to want to move the stuff very easily. So what do they do here? You'll notice that the hill is entirely covered. It's been paved over in concrete. Now what does that do? Now when it rains, the water is going to hit the concrete and just slide off and over here into this drainage area. Well, we don't let the water touch that small soft material at all, so therefore the water can't move it. So this is a pretty extreme measure, and this is, you can coat a hill in concrete, and what that does is it keeps the water from touching the material at all, and therefore it won't be able to move it. So once again, in summary, one other method that can be used to help control erosion is to pave a hill in concrete. That way the water cannot touch the soil at all, and if the water can't touch the soil, it can't move it.
Here you can see some examples of hills that have been covered in concrete to keep water from touching the hill at all. Because remember, if the water can't touch the stuff, it's not going to be able to move it.
So let's talk about battling creep erosion. Here I've got a really steep hill. It was so steep that we had to build a retaining wall to help keep the sediments up here and keep the shape of the hill. Well, it rains and that hill is going to get wet, and remember, erosion is the movement of stuff by water or wind with the help of gravity. Well, when the water gets in this soil, it's still going to get pulled down by gravity. So if this soil gets really, really wet, it's really going to try to push on my wall, and I got to be careful because my wall might eventually be pushed over by that slow movement of the soil. You can actually see it here, how this wall is cracked now at the joint. This section of the wall is being pushed on enough that now it has come separated a little bit from this one. It's not real bad, but if it continues over time and too much pressure builds up, this section of the wall could fall over and I lose the slope of my hill. So how do we help keep this from happening? Well, remember, this is caused by water moving through the soil behind the wall. So if we let the water move through the soil, then it'll move on down the way and we won't have the creep erosion. It's one of the reasons why you have these right here. You have these little drains that allows water to be drained out of the soil, and that way the water will flow out the bottom and leave the dirt behind the wall, and my wall won't get knocked over. Notice along the top we have a drain for water, and what this does, it allows the water to get out from behind the wall and go somewhere else so that it doesn't soak into the ground, make the ground heavy, and want to push the wall over. So once again, the number one way to fight creep erosion is going to be do something with the water, because it's the water getting into the soil that's causing the erosion.
Here's a case where they built this fancy new wall and they didn't handle the water well. Notice the two different colors here. This block here and this block here. They had built this wall and it was all this block here. Well, they didn't let the water drain well enough, and so much water got behind the wall that it wanted to move, and what happened? The wall fell over. Well, how'd they fix that? Well, they went back and rebuilt the wall, but then look, they put in this drain here, so now any water back here is able to come out the bottom of the hill and not build up so that it pushes the wall over. So, in summary here, To limit the erosion by controlling water, you got one of two choices. You either make water slow down or you make less water. Period. Those are the two choices that you've got. And there's one other thing that can help us here with actually both of these aspects, and that's to build the dam. Rivers cause a lot of erosion. There's a lot of water moving through a river. Remember, a dam can control the amount of and the speed of water in a watercourse. So this is another benefit of dams, is that they help to control erosion by controlling the amount of and the speed of water in a river or a stream.